In this video, we're going to talk about topic 3.6, which is calculating higher order derivatives. Our essential question is, how do you find a higher order derivative? And our I can statement is, I can find a higher order derivative. So basically, the basis of this is you can basically just keep taking derivatives. You can always take the derivative of a function. So if you have the derivative of the original, you can take the derivative of that, and we call that the second derivative. Our original function, and this is a good way to think about this, is what we can usually consider the position function when we're talking about some physics. When we take the derivative of it, we call it the velocity function. And we take the second derivative, we call that the acceleration. We don't use the next one quite as much if we actually go to third derivative. It's called the jerk, okay? But you don't see that one. You'll see the velocity and the acceleration. So this table has a bunch of different ways to show the notation. You just keep adding prime symbols until you hit the fourth derivative. Once you hit the fourth derivative, you put a little number in parentheses. And then on the dy dx notation, you just keep changing the exponent on the d and the x. And there's a little note over here to tell you why. So why does the second derivative notation look like d squared y over dx squared? So you got to think of that as taking the first derivative, taking the derivative of the first derivative, which we would write d dy dx over dx. And then when you multiply that out, you end up with d squared y over dx squared. All right, so let's try a few of these. So we're going to find this, it says find the second derivative. That's what this double prime means. If f of x equals 2x cubed minus cosine x plus natural log x minus e to the x. So we always have to find first derivative before we find second derivative. So 2x, derivative of 2x cubed would be 6x squared. The derivative of negative cosine is negative sine x, so that's going to go positive. The derivative of the natural log of x is 1 over x, and the derivative of negative e to the x is negative e to the x. I'm going to spend one line rewriting that because of the 1 over x part. Remember, that's to the first power, and I got to bring this upstairs to integrate to the next level here. So it's x to the negative 1. All right, we're going to take the second derivative. So this derivative of 6x squared is 12x. The derivative of sine x would be cosine x. The derivative of x to the negative 1, we're going to bring the negative in front, so it would be negative 1x. Subtract 1 to the negative 2, and then minus e to the x. I could spend one line cleaning that up a little bit by making the third term 1 over x squared and getting that exponent positive. Let's do this one more time in example 2 here. So it says that it wants us to find the derivative. You'll notice that we have a chain rule going on here because I have that 4x. So I'm going to use u as 4x, which means that u prime is going to be 4. All right, let's try to start taking the first derivative. So I'm going to use dy dx. Since they use that notation, that's why I'm using the dy dx notation. So the derivative of 4, this is actually 4e to the u. I should have really rewritten that. So the derivative of 4e to the u would be 4e to the u, and then times the derivative of the inside, which we learned was 4. I'm going to rewrite that now. So that's the same thing as saying 16e to the 4x. You'll notice, hopefully, that my u is the same there. So I actually have the same u. Ooh, didn't change colors. I have the same u for my chain rule for the second derivative, so I don't need to redo that. Probably what I would do is rewrite this as 16e to the u. And now we're going to take that second derivative, y over dx squared. So the derivative of the outside function would be 16e to the u. And the derivative of the inside from before would be 4. And then we're going to replace. So 16 times 4 would be 64 e to the I'm sorry, I'm going to substitute the u in. So e to the 4x.